Hello guys, this is another tutorial in Java. My name is Mohammed Asif and I am working in software development for last 20 years, and here I am going to share with you something about data types. The first data type that I am going to cover is integers. Then in next videos we will cover about long and double and float, etc. So let us begin and go straight to the topic. So we are going to create a class which is named my integers, and in this class I will show you how integers are used in Java. So let us create the main method and let us straight away initialize an integer. So this is a very basic and first example of creating an integer variable. So this is the type of the variable, then this n1 is the name of the variable, this is the assignment operator, and this is the literal value. And we can print this out using system.out.println, and we can put n1 in here and then we can run it. This is an Eclipse IDE which I am using, and in this we can use, actually we can write down main and then we can press Control and spacebar together to get this option of generating the main method like this. Actually this is already generated, but if we want to generate, we can generate it like this. Out of the main method we can generate the main method. So this is a shortcut, and then we can, how to run it, we can actually combine Control plus Alt Shift plus X, and after that we get this menu, and here you can see for running the Java application we can do Alt Shift X and then press the J key. So we can do the same here like this, Alt Shift X and then J. So this runs the code here, and this is the Eclipse version. We can see the Eclipse version from here about Eclipse IDE. So this is the version with this build number, and version is written here 4.25.0. so this is the IDE I am using. Okay, so now back to the topic. So here we have seen that we can initialize an integer by using a literal like this. This is called literal, the value that we assign. So similarly, if we want to assign it again, we can do another assignment, and let us use binary literal here. So for example, if we put the 0b as prefix, and then we can write down the binary notation, for example 1111. So what is this number? This is not 1111, rather this is a binary number, binary representation of a number. And what will it return? It will return us the number 15. You can see it has returned number 15. Similarly, we can have another notation here, that is the octal notation. For example, if we put 0 here and we put here like 7 and 1, so will it print out 71? No, it will not print out 71. Rather, we will see what it will print. it has printed out 57 because this number is an octal representation of a number that is converted to decimal and then printed out here as 57. So similarly we can assign it using we can have the hex representation like F and then 1. So what will it return? Let us see. So it has returned 241. And if we want to convert this integer into we want to print this integer into binary representation, this is like, let us reassign 1 here, so or like 9 for example, sys out, and then this is also a shortcut, like you print out sys out, then you press control spacebar and it gives you this option. You can either press enter or you can you can click on it and it will generate it. Okay, you can double click on it. Okay, and then you print it out like integer dot this is actually integer is a wrapper class and it has some helper methods that these are static methods which do not need an instance, rather these are class methods. So we can use binary string, hex string, octal string, we can do anything, like we can print it out in binary format, then we can see what it will return. It has returned 1001, right? And then we can print out it as an octal number using the same octal method here. Similarly into the hex number, and you can see what it will return. So it is smaller than 10, so it has printed out 9. But what about number 11? How it will be represented in hexa format? So let us put 11 here and then we run it again. So you can see it has it has printed out B, and for 10 it will return, it will print out as A. Like in hexa format the numbers go from 1 to 16, after 10 it becomes A, B, C, D, like that, and up to 10 up to 9 it remains the same number, but after that it changes. So this is how you can initialize these numbers. So normally we don't use these literals, but you need to know these if you are going to interview somewhere or you want to take some exam, some certification exam, then you should know about these tips. And these are actually language features, those you need to know. So now let us do something else. Now I am removing this. Now let us see, let us check what are the binary operators available. So now if you want to add, you can do it like n1 plus n2 and then sys out, and so this is a simple operation. You will get 5 here, you can see, and if you do minus, then you will get a negative number because you are actually subtracting 3 from 2, so you will get a negative number here. Then similarly if you do a multiplication, you will get 6 here. They are all very good and easy examples, so you will be thinking about what's special about it. So there is nothing special, but this is just to have a complete look on the operators. So let us do a division now. This is the division operator. So here the trick is present. So what will it print? You can see if you divide 2 by 3, what will it return? So let us use a calculator. So and then we do 2 divided by 3, it is 0.66 and something like that. So what will happen here? It has returned 0. And why it has returned 0? Because this is an integer operation, because two integers are involved here. So we cannot get the correct result until we have a double operation here. And for a double operation, what will we need? We will need, for example, let us do it here like this. Double n1 divided by n2. So now this will return us correct result like double n1 divided by n2 double n what is wrong here? Oh, actually the parentheses need to be around the double. So now this n1 will become a double, and then the whole operation will be a double operation, and it will return a double value. And then if we print it out, we will see the correct result. So here it is, you can see we got the result. And but what if we assign this, why we created this n underscore? Because after double operation it will be a double result as well. For example, this will not be assignable to an integer. You can see it is giving a compile time error. This code cannot be compiled. If we do int here, then it will be casted back to integer, and when it will be casted back to integer, it will truncate all of this again. So let us run again, and you can see it is again 0. So this is something that you will get as some trick questions in exam or in your interview questions, etc. So you will have to remember this. And so let us now go to some other operations. There is an operation with AND symbol. So what does it do? It is like it operates on the bits of the integer. For example, you can see this n1 can be represented as binary number, like we know about that we have to integer dot to binary string 2. So if you write it and then you run the program, you will get 1 0, and then for 3 you will get 1 1, and then if you do an operation on them using AND, what will it return? It will return like 0 1 you will get 0, and then 1 1 you will get 1. So it will return this 1 0, right? And what is 1 0 in integer? We can actually have it here, n3 is equal to 0, b 1 0, and then sys out this out, and then we do it here n3, and then this number and the result of this number should match. So let us run it, and you can see this is n3, which is 2 here, and here this 10 actually represents 2. For example, we can print it out in binary format, the format, and now you will get it. So you can see this is same. Just to confirm, this is 10 and the next line is also printing 10. So this is how this operation is working. This is the AND operation, and when both bits are 1, the output bit is going to be 1. When one of the bits are 0, then the output bit will be 0. So this is the AND operation. And now let us go to the next operation, the next binary operation. So let us copy it, and then here we go to, so this is a hat operator like this, and it also operates on the bits, and when both bits are 1, the output bit is going to be 0. When both bits are 0, the output bit is going to be 0. And when both bits are either when one bit is 0 and the other bit is 1, then the output bit will be 1. It works like this. It is exclusive OR. So let us see what happens here. Let us comment this out and just have this here. So now what will happen here, let me also comment this out, and then we see like this. So what will happen, this bit will return us 1, the second bit, when we apply the operation hat on these two bits, and the first bit of the two numbers will return us 0. So it will be like 0 1. So let us now uncomment these, and this is like 0 1. So let us now run it. You can see this represents 0 1 here like this. So and we have got the result, and this is how exclusive OR is working. So there can be any number. You can have 20 and 30 here. The operation will return some other values, or other 33. Actually this is the numbers I have actually stopped using this n1 and n2, n1 and n2. Let us use those numbers, n1 and n2, and this is like let us not use this anymore, and then here 20 and 30. Then what will we get? We are getting some other number, and actually we are using this integer to binary, but let us print it out in decimal notation as well. So if we do it like this, remove the method and then just have it, so it will be printed out in decimal number. It is 10. The decimal number is 10. Decimal notation of the number. So we can have it like this. So you can see it is returning this, and we can actually, this is I just used it for demonstration purposes. Otherwise we use the decimal notation more often than any other notation. So it is like this, 20 and 30, and when they are used in an XOR operation, they have returned 10, which is represented in a binary notation like this. Binary notation of result and then we can see it like this. And now let us check one other operator. Let us just copy this and here, and then we do it like this, and then let us use another operator. This is a unary operator that will not be applied to two operators, rather two operands, rather it will be applied to a single operand, and it is the notation like this, wave type sign. This is a like a and it is called tilde operator, I think. So what will it do? It will actually invert the bits. The 1 will be converted to 0 and 0 will be converted to 1, like that. And so let us apply it to 20. So what will it return? It will return minus 21. Let us see. And we run it. This is minus 21. And when we will apply it to the N2, what will happen? It will return minus 31, like this. And when we will apply it again to the same numbers, like we can apply it like this again, like here, let me write it down like the minus 31. So it will return back the original numbers like this. You can see 20 is returned back as 20 and 30 is returned back as 30, and like this. And if we do some binary notation just like we have done here, so we can do the binary notation display as well. So we will find out what happened here. Integer.toBinary string and this tilde operator, and then I am just removing other lines to clarify it more easily. So you can see all of the bits, because there are 32 bits, so all of those bits, those 0 bits which are, for example, they are not showing up here, but they are there in an integer. There are 32 bits, so all of those zeros are converted to 1, and then this 1 is converted to 0, this 0 is converted to 1, this 0 is converted to 1, this 0 is converted to 1. And when all of this has returned us minus 21. The first bit is actually the sign bit. When it is 1, we get the minus sign. When it is 0, we get the positive number. So we can see it here. Another thing that is very important and very interesting to check. Let us go to the maximum value of the integer. So, and we print it out. This is n1 plus, and then the binary binary representation is like Integer.toBinary, and this is n1. So let us see what it prints out. So it has printed out these bits, and how many of them are there? These are like we can put them here, and then 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 and 31. So there are 31 bits. The first bit is 0, which is not printed out here, but it is there. The integers are 32 bits. Now let us put this into n1 like this, 0b and like this, and then syst out n1. So it should print out this value. So let us do it again, and so it has printed out the same number. And now let us change this bit 0 to the first bit. I am changing it to 1, and now let us run it again. So it has printed out -1, and if we print out the binary representation here, which is like binary is equal to Integer.toBinary at n1. So we will see. So this is the binary representation of -1, and then the minimum value, we can have the minimum value n2 Integer.minValue, and then syst out, and it is like n2, and the binary representation is Integer.toBinaryString. This is n2, and now we are printing it out. So you can see when all of the other bits are 0, then this number is the smallest number possible in integer data type. And now there is a question that what will happen if we do n1 equals Integer.maxValue. Like let me just have this removed, and now let us see what will happen when we add another number in here. It will not fit into the integer type, right? So what will happen? It will result in overflow. And what is the behavior of the overflow? For example, we will see here, let me do it. So it has returned the minimum number possible. And we do here like +1 +2. It has shown us this 47, 1 greater than the minimum number. And similarly, if we do for example, let us do n2 is equal to Integer.minValue, and we do system.out.println and n2 -1. So what will happen? It will do an underflow, and it will result in the maximum value possible. So we have to take care that whenever we are using the integer, our value literal must be within this range. Otherwise we will get unexpected results. So this is all that I wanted to share with you in this first tutorial about integers, and there will be more tutorials coming up and for other data types as well as for integers, and I will continue uh, sharing with you this knowledge. And thanks to all of you, and if you like this video, please like this video in YouTube as well, and also subscribe to my channel, and please keep watching my tutorials and supporting me. Thanks.